Hello, algebra students. Mr. Lawrence here, and today, after today's lesson, you're going to be able to say, I can calculate exponential growth and decay. Now, to be able to do this, we have a formula. It's actually pretty easy, but you have to understand the parts of the formula. The formula is A equals P times the quantity of 1 plus or minus R to the power of T. Now, we'll explain what each part is. First of all, let's start with T. T should be obvious. T is the time. But this is important. It must be in years. It's the time in years. So if they said for 6 months, you wouldn't put a 6 there. That would be 6 years. You'd put 0.5 or 1/2 there. Okay, R is the rate. And when you do your rate, you have to have it as a decimal. And I know some of you don't understand how to convert decimals and fractions and that kind of stuff. So let's just say if I had a 2% rate, my decimal is 0.02%. I just divide by 100. Okay, if my rate was 12%, well, the decimal is 12 hundredths. I divide by 100, right? Just like we did in scientific notation. If I had a rate of, say, 16.8%, well, the decimal would be 0.168 or 168 thousandths. Okay. Now the plus or minus depends if it's increasing or decreasing. That's all it means. If it's going up, we'll use plus. If it's going down, we'll use minus. The P is the principal, not like Mr. Morgan principal. It's the amount you start with. That's the starting amount. Okay? And then A is the amount after T years. The amount after T years. Okay? So let's see how to use this because it's really pretty simple. By the way, I'm going to use that formula a lot. I'm going to always use A equals P times the quantity of 1 plus or minus R to the power of T. And let's say I had 150,000 people living in a town. The population is increasing at a rate of 4.5%. How many people will there be in 7 years? All I'm going to do is fill in everything I know. Well, I'm searching for A. How many people there be? The principal is 15,000. Excuse me, I think I said 150,000 when I read it. Pardon me. We're increasing, so it'll be plus. And remember, I need to divide this by 100 to get my decimal. And so it'll be 0.045. My time in years is 7. And from right here, I'm just going to go to a calculator, and I'm actually just going to enter it in. 15,000 times the quantity of 1 plus 0.045, and I'll raise that quantity to 7th power. And when I do that, I get... Now, in terms of people, that doesn't make sense, so my answer could be about or approximately 20,412 people. Now, I didn't round up because I don't have 13 people yet, okay? But if you say about or approximately, that should be a sufficient answer. Now, I'm not going to do the how many 8 years ago problem yet. I'm going to come down here to this one and say this time your home is worth $180,000. Unfortunately, due to tough economic times, its value is decreasing at a rate of 2.4%. What will the value be in 12 years? Well, A equals P times the quantity of 1. In this case, it'll be minus R to the power of T. Why is it minus? Because I'm losing, my house is losing value. Okay, I'm going to fill in everything I know. So A is going to equal 180,000 times the quantity of 1 minus, remember, divide by 100 to convert that to a decimal, 0.024, and then raise it to the power of years and time. I can go to a calculator at this point. 180,000, 1 minus 0.024. Oops. And I'm going to raise that to the 12th power. And it looks like that in 12 years, my home would be worth approximately $134,483.91. The decimal ended up being like 0.0968, but since I'm talking money, I went ahead and rounded. All right, pretty simple stuff. Now let's just take a look here at these years ago problems, okay? These are actually super simple, and I had a student show me how to do them. I was doing them a more difficult way, and several years ago, a student said, hey, you know what? If I think about 8 years ago, that's like going back in time. In other words, my time is going to be -8. And so I do the same thing. A equals P times the quantity of 1 plus 0.045 to the power T, and I fill in what I know. 1 plus 0.045, and then make my time negative. And if I do that, I can get my answer very simply without making the problem too complex. And I really like it because the negative time is just like going back in time. And so in this case, the population of town was only 10,547 approximately. Okay. Coming down here to the money problem, 5 years ago, let's pretend this, you've owned this house longer than that. I'm going to use the same equation. I'm just going to fill in what I know. The principal didn't change. And I'm going to be losing. Oh, did I make a mistake up there? No, I didn't. Good. Okay, I'm going to be losing a rate of 2.4%. And it's 5 years ago. I'll make my t negative. And then all I have to do is type that in, 180,000 times the quantity of 1 minus 0.024, and I'll raise that to the -5th power. Oops. And then it means that the house was worth approximately $203,246.66. So we're just basically using the formula and plugging and chugging. But it's actually pretty cool because you can take this value, like maybe you get some money for graduation or your commencement or something, put it on a CD at the bank, and you can find out what it's going to be worth when you get out of high school. All right, that was 2 quick examples, technically 4. It should be pretty easy stuff. We'll get some practice with this in class tomorrow. Mr. Lawrence signing off. Good night, everybody.